All right, we're at section 15.4, electric field lines. Now, electric field lines are simply a mental construct to help us visualize the, the electric field around charges. So let's start over here with the positive charge. For a positive point charge, the lines radiate outward. For a negative point charge, the lines converge inward. So positive, they go out, negative, they go in. So the negatives attract the field lines, the positives, they emanate from, the field lines emanate from the positive charge. So the electric field is tangent to the electric field lines at each point. The number of lines is proportional to the field strength. Drawing field lines. So the number of field lines leaving the positive charge equals the number terminating at the negative charge. This is because these are equal. The positive charge is equal to, in magnitude, to the negative charge. So you have an equal number of of lines coming out of the positive and going into the negative. So lines begin on positive charges and end on negative charges. Now, the number of lines is proportional to the charge magnitude, and field lines do not cross. Okay, so here's two positive charges, and notice that they repel each other, so the field lines are deflected and are repelled away from each other. We'll be able to see this when I do the magnetic filings on magnets. You can see something similar, but again, this is just a visualization. So here, if you want to look at the intensities of the electric field at A, B, and C, well, it's greatest at A because it's closest to the charge, and that's where the field lines are most concentrated. If you look at B, it's further away from the charge, and they're a little more spread out. And at C, it's zero because the field lines are repelling each other at this point. Okay, now let's look at unequal charges. Now, again, this is just a mental construct. This one is negative Q, and this one is plus 2Q. So let's start here by the 2Q and count the lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there's 16 lines emanating out from the 2Q. What do you think is going to be coming out or going into the minus Q? It should be 8. Let's start here at the Q. Let's go 1, 2, 3, 4, 5, 6, 7, 8. Sure enough. So you've got 16 lines emanating out from the 2Q and 8 lines going into the minus Q. Okay, and that's it for this. Let's play a little bit with the our FET simulation. It doesn't really show the field lines. Let me restart this, reset it, and let's put a positive here. Let's take out the, well, I don't know. I think we need the field lines. Let's try to position it right at a central point there. And let's put another one right here, and we'll try to put it. So if you were to follow these lines, you would see that there's that dead spot here. You can the field lines, well, nothing I can say really, but right here in the center, you see that the force is 0, so there is no electric field right in the center. let's do a positive and a negative charge. So let's take this one out, and let's put this one in. Let's try to position it. And you can see it looks something similar to what we saw in the in the PowerPoint slide, where you have these going around. It's a little bit restrictive. We can't make the images the way they do in the PowerPoint, but I think you get the idea. Okay, so we'll end here, and the next one is conductors in electrostatic equilibrium.